Okay, good morning or good afternoon. Quadratic functions are our new function that we're talking about. So let's look closely at their parent function. A parent function is like the most basic form of that type of function that there can be. It's almost like functions can be built off of that function. So the parent function for a quadratic is this: f of x equals x squared. It's one of the most basic quadratic functions that there could be. So let's look at a table of values for this one. So I'm going to go down a couple lines. Your note should look like mine. Oops. So we have x and f of x. And for this function, your outputs equal whatever x is, oh my goodness, squared. We're going to go from -5 all the way to +5. So when our input is -5, what's -5 squared? -5 times itself. That's going to be a +25. So be careful on that. Over here, we're going to sketch the graph of this parabola. So make your graph look like mine. I'm going to label my x-axis. This is your y-axis. I'm going to do 1, 2, 3, 4, 5. I'm going to do 1, 2, 3, 4, -5. Try to keep them like spaced out as best you can. We're going to go by 2's up here on the y for your scale. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Now that's plenty of room to graph what I need to graph. I only wrote those numbers in because I write too big. That'd look messy. Okay, so let's put in -4 for x. -4 squared, -4 times itself, or -4 times a -4 is a +16. So that first point, -5, 25, if I were to graph it, I'd go to -5, and then I'd go up to 25, which would be about right here. So that's that point here. When x is -5, your y value is +25. -4, 16. When x is -4, we are at 16. -3 squared. -3 times -3 is a +9. -3, +9 would be right in the middle there. -2 squared. That would be a +4. Pause the video whenever you need to, like if I'm going quicker than you can write. -1 squared. -1 times -1 is a +1. So that would be here, kind of in the middle, because that was a 2. 0 squared. 0 times 0 is 0. 1 times 1, or 1 squared, so you're going to fill in all of these. 2 squared, 3 squared, 4 squared, 5 squared. Remember, squared means something times itself. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. So let's plot those points. 3, 9, 4, 16, 5, 25. Looks good. Okay. Now, if you remember from the previous notes what a parabola or what a quadratic should look like, and it should have more of a U-shaped curve. U-shape. So we are going to connect these, but make sure you curve that bottom piece. U-shape. Does anyone remember what that U-shape is called? Not a V. Make it very curvy on the bottom. It's called a parabola. Okay. So while we're here, look at this parabola. It actually has something called symmetry. And the symmetry means there's like a mirror image or the same on both sides. It's almost like I could fold this paper up and they'd have a match. Points match up, points match up. You can even see the symmetry in the table. Here we have 0 right here in the middle, this point. And then you have these matches, 1 and 1, 4 and 4, 9 and 9, 16 and 16. You have that match happening. So there's that symmetry happening here. And remember what table property you would see in a quadratic? 25 to 16, that goes down 9. 16 to 9 goes down 7. 9 to 4 goes down 5. 4 to 1, that goes down 3. So there's no first differences in common, but we do see those second differences. They are all increasing by 2. So there's those second differences again. We'll just throw that in here. Second differences. What else do we want to chat about? Let's talk about the domain. Domain and range. So the domain and range you can get by looking at the graph or the table or the function. Domain refers to your x values. So think about your inputs. What number can we square? Like what number can you do a number raised to the second power? Were we able to do negative numbers raised to the second power? Yes. 0 to the second power? Yes. Positive numbers can be raised to the second power. Can decimals be raised to the second power if you had a calculator? Yes. So your domain is all real numbers. And on the graph, you can see that it's all real numbers because there would be little points in between here. I have no restrictions. It's keeping going left. It's keep going right. So your domain is all real numbers. Now that's only going to be true when you have a function, when it's attached to like a word problem. That's when it changes to those practical domain and ranges. Range. Now the range is not all real numbers because it looks like no matter what I put in for this particular problem, my lowest y value is a 0. I don't have any negative y values. This is my lowest y value. So we would say the y are greater than or equal to 0. A few other important pieces. One is that vertex point. The vertex is right there, this point. That's a special guy. We would name it 0, 0. And your vertex could either be a maximum point or a minimum point, depending if you have an opened up or an opened down parabola. You'll have a maximum when it looks like this, and you'll have a minimum if your parabola looks like this. For the parent function, what's your vertex? Is it a maximum or a minimum? For this particular problem, it's a minimum because it's your lowest point. The next, so that's an important vocab word. The next one is axis of symmetry. Axis of symmetry. So your axis of symmetry, special word, that word axis means the word line. It's the line that splits the parabola in half or makes it symmetrical. In this case, it's going to be a vertical line. And if you remember from like way back in like chapter 3, vertical lines are x-equal equations. So a vertical line in this graph that we're talking about is right here. And since it's not really part of the function itself, it's like an invisible line, we have it dashed. So your axis of symmetry is x equals 0. Okay, now we have two other newer pieces of characteristics we want to chat about. And that's called increasing and decreasing intervals. Increasing interval and then decreasing interval. So this requires you to always read the graphs from left to right. Left to right. So these are your potential looking graphs. You might have a parabola that's opened up, and then you might have a parabola that's opened down. Here's the vertex. When we're talking about an increasing, so if I read it from left to right, read graph from left to right. If I'm reading this graph from left to right, from here to here, notice how my points are going down, stop at the vertex, and now they're going up. So we would consider this side as your increasing interval. If my parabola is upside down, if I read from left to right, notice how over here they start to go up, vertex, then they go down. So this is your increasing interval. These are always written in terms of your axis of symmetry because that's what cuts your graph in half. The decreasing intervals. So again, you could have a parabola that looks like this. You could have a parabola that looks like this. Here's your axis of symmetry, which is an important part. I'll get to that in a second. So a decreasing, if I'm reading it from left to right, these values are going down. This would be my decreasing interval. From left to right, if my parabola is upside down, it would be this way. They're going down. Going up, think of it as a hill. Going up the hill, then down the hill. Going down, and going back up. So because the axis of symmetry cuts it in half, and that's where it does the changes, these are always going to be written in terms of your line of symmetry. So you're going to do X, and then if it's to the right of your axis of symmetry, let's write that. Right of AOS. Then you would do X's are greater than whatever your AOS number is. If it's to the left of your axis of symmetry, like this one, then you would answer X is less than whatever your AOS is. So these symbols are important. This would be your answer. For the decreasing ones, so you would write X over here. This is to the left of the AOS. So X is less than whatever your AOS is. If it's decreasing to the right, then you would write X. If it's to the right of the AOS, then it's X is greater than whatever your AOS number is. So for your parent function, I'm going to squeeze it in here. Your increasing interval would be X is R. So notice how your graph is going down and then it goes up. That's to the right of your AOS, so it's X is greater than 0. And then the decreasing interval, X is R less than 0. So that's saying when X's are greater than 0, these numbers here, your parabola is increasing in value. When your X's are less than 0 to the left, those numbers are going down. It's like a newer concept, so you're going to have an activity to do with that in a second too. Let me show you that. But these would be the rules that you want to follow. or kind of think about. They're always also going to be opposites. So notice how this, you'd have a parabola that's opened up. If it's increasing, it's going to be greater than your AOS, and then the other one would be less than, like if it's opened up. If it's decreasing, your increasing side would be less than, and then your decreasing side would be the opposite. So these are always opposites, depending on if it's opened up or down. Okay, have fun. Bye.